I think internet band ho gaya tha. All right, we're back. Can you guys hear me properly without any lag?
Yes, miss.
All right. Okay, so let's quickly start 17. Says the complex number u and a complex number w satisfy the equation u minus w is equals to 4 iota and uw is equals to 5. Solve the equations for u and w, giving all the answer in the form of x plus iota y, where x and y are real. Okay, so I'm going to, we're told that u and w are both complex numbers. Can I say that u is, let's say, a plus iota b, right? So notice something between the two numbers. Notice this. You're multiplying two complex number, but the product is not complex, it's real. What's going on here? U times W is 5. This is real. How is that possible? Let me give you two complex numbers, like 2 plus 3 iota, and let's say 1 minus 2 iota. If you multiply these, where does the iota go? How come this product does not have an iota? Because if you multiply this, what do you get? You get 2 minus 4 iota, then plus 3 iota, and then minus 3 times 2, 6, and then iota square is another minus 1. So if you simplify this, you do get an iota term. But why is there not an iota term when we multiply it? That is because that only happens when U and W are conjugate pairs. One is 2 plus 3 iota and the other one is 2 minus 3 iota. For example, now let's multiply. 2 times 2 is 4, then minus 6 iota, then plus 6 iota. And then we have minus 9 iota square, which is also minus 1. So now the real parts are gone. Sorry, the imaginary parts are gone. And you just have 9 plus 4. So U times W equals to 5 is only possible when U and W are conjugate pairs. Conjugate pairs. Okay. That means W would be A minus iota. All right, I'm going to substitute these in the given two equations. One is U minus W is equals to 4. Let's do that. U is A plus iota B minus A minus iota B equals to 4. So we get 2 iota B equals to 4. So B equals 2 upon iota. But we can't have an iota in the denominator. That needs to be fixed. So we have to multiply with iota here and divide with iota here. So that gives us 2 iota upon minus 1 because iota square is minus 1. So we get minus 2 iota. So B is minus 2 iota. Then kuch galat hua. Let me just quickly recheck. A plus iota B and A minus iota B is equals to 4i. I have missed an I here. Can you guys hear me? Or am I disconnected? आवाज आ रही है?
जी मिस आ रही है.
All right, good. अच्छा मैंने खुद ही अपनी वीडियो बंद कर दिया. I guess that is what happened. All right, so what I did wrong was I did not copy 4 iota from the question. So if there's an iota here, then that makes the working pretty easy. ये सब खत्म हो जाएगा. Internet is really bad today. Sorry about that. Just give me a second. Okay, there's an iota here. And then iota on both sides get cancelled. There's an iota here. Iota and iota gets cancelled. So B is just 2. All right, now we have to find A. To find A, I'm going to use the other given equation. U times W is equals to 5. So UW is equals to 5. So I know A plus 2 iota times A minus 2 iota equals 5. So now we have to find A. Let's multiply A square minus 2AI plus 2AI. Then there's a minus sign. 2 times 2 is 4. And iota square is minus 1 equals to 5. So I'm getting A square plus 4 equals 5. So that's A square equals 1. So I'm getting A equals plus minus 1. So we get 1 plus 2 iota and we get minus 1 plus 2 iota as the values of U and W. Let me check the answer. Hold on. Yes, they're correct. So there are two values of A, 1 and minus 1, but there's one fixed value of B, which is 2. So any one of these could be U and any one of these could be W. Because they were supposed to be conjugate pairs, which they are. किसी को भी W कह सकते हो, किसी को भी U कह सकते हो, it does not matter. All right, now let's move on to part B. 1. On a sketch of an Argand diagram, shade the region whose point represents complex number satisfying this inequality Z minus modulus Z minus 2 plus 2 iota less than equals to 2. So that is a circle whose center is what? Who can tell me? What's the center of this circle? And then what's the radius of this circle? Yes, class, what's the center of this circle? The one marked in green. You guys have forgotten, how do we find the center? You equate this to 0. And then you get Z is equals to 2 minus 2 iota. So the center is 2 comma minus 2. All right, and the radius is 2. So let's plot this. So we have 2 minus 2. And the radius is also 2. So it looks something like this. This is the circle. This would be 4. This would be minus 4. All right. And the center is what? 2 comma minus 2. All right. So we've plotted the circle. And also plot argument of Z is less than equals to minus pi by 4. Now, you can't just select any point on the circle. There's another condition that the argument of that point or the locus of points that you select should have an angle less than minus pi by 4. First, tell me what's minus pi by 4 in degrees, so that we can comprehend it better. What is minus pi by 4 in degree, guys? Pi is 180 and 180 divided by 4 is 75. So it's a 75-degree angle and it's in the negative direction. So if I plot it, it's going to exactly pass through the center because this would be 45, right? It must pass through 2 and minus 2. And I'm going to write pi by 4 instead of 45. In fact, minus pi by 4 because it's a negative angle. All right. In fact, we're not supposed to write minus pi by 4. That is implied because it's a clockwise. All right. Now we only have to choose those parts in the circle whose argument is greater than negative pi by 4. Sorry, less than minus pi by 4. So which part of the circle should I shade? This blue one or this pink one? Which one of these sides have an angle less than minus 45? Blue or pink? What is less than minus 45? Less than minus 45. That would be minus 50, minus 60, minus 90, and so on. So it's this side. You shade this side of the red line. Okay, there's another condition there, which is the real part of z should be greater than equals to 1. Okay, but let's say if I consider this point or these points on the inside the circle, here is the real part greater than and equals to 1? No, 1 is here, 1 is somewhere over here. So it says that shade that region where the real part is greater than equals to 1. That means we don't shade this region. I have to clear some part of the yellow region. This has to be cleared. This is not acceptable. Only the right side of the blue line is acceptable. So this goes, and now that is our correct locus of points shaded. So you have to shade a region inside the circle. We've done that. You have to shade the region where the angle is greater than minus pi by 4. So that's going to be like minus 50, minus 60, minus 70. So now it had to be below the red line. And the last condition on the Argand diagram is that the real part of z should be greater than 1. So this is the real part. This is 1. So we have to shade the region that is towards its right, where the real part is greater than. Let me confirm that is correct. Last part of the question is calculate the greatest possible value of real value of z for the points lying in the shaded region. Now in this yellow region, which point will have the greatest real value? Which point in the yellow region will have the greatest real value would be this point. क्योंकि देखो it will have the maximum possible value on the x-axis, which is the real axis. So we have to find this value of x right above this point. So how do we do that? We know that this is 45 degrees, right? We know that much. What else do we know? We know the radius of the circle, it's 2. So यहाँ से यहाँ तक it's 2. The radius of the circle. 2. And I can find the remaining part of the black line. Just a second. The remaining part of the black line is the length between the origin, which is 0, 0, and the point 2, minus 2. We have 0, 0 here and 2, minus 2. So what is going to be this length? This is 2 units and this is 2 units. Apply Pythagoras theorem on it. Square root 2 square plus 2 square. That's square root of 8, which is 2 square root of 2. the further simplification. So this length would be 2 square root of, which means that this entire length from here all the way till here is 2 plus 2 under root 2. Right? So I have a right angle triangle where the hypotenuse is 2 plus 2 under root 2. This angle here is 45 degrees or pi by 4 if we're ignoring the sign. And what do I need? I need this length because I need to find this value of x here. So I can use cos. Let's do that. Going to be cos pi by 4. Going to be cos pi by 4 is equals to x upon hypotenuse 2 plus 2 under root 2. So multiply cos pi by 4 with that. What is cos pi by 4? Set to radians and then cos pi by 4 is under root 2 upon 2. And with that, you have to multiply the denominator. And that's x. I'm going to bring out a 2 from the numerator. And it will be 1 plus under root 2 inside. And this 2 cancels out. And when we multiply the rest, we get under root 2 plus 2. So that's the maximum value of real value, maximum value of real part of the shaded region. Again, if you don't redo these questions, you will definitely not be able to do a similar question that might come up again sooner or later. So please dobara kar lein. It's ideal to redo all the questions you've done with me in your own time. Okay, let's start 18. Hope we get to finish it. Complex number W is defined by this. Find the modulus and argument of W square and W cube. Okay, polar form. Been a while. Okay, what I'll do, I'll first plot this just to revise what is polar form. -1 and iota is also 1. So here's W. -1, comma 1. I need its modulus and its argument. What is its modulus? This length here. Let's find that out. Apply Pythagoras on this length 1 and this length 1. So it would be square root 1 square plus 1 square, which is what? Square root of 2. So the modulus of W is, just of W, is square root of 2. Now I would be needing the argument. Argument is written like this: cos argument plus iota sine argument in polar form. Although you haven't been asked to write it down in polar form, so you may not need to do this. All right, now I need the argument of that point. Argument of that point is this angle. How do we find this angle? I'm going to find the opposite angle, the adjacent angle first, and then subtract it from pi. So the adjacent angle is going to be tan inverse 1 upon 1, which is pi by 4 or 45 degrees. So the rest of the angle is going to be pi minus pi by 4, which is 3 pi by 4. So the argument of W is 3 pi by 4. Or you may write it here in polar form. वैसे इसकी बिल्कुल भी जरूरत नहीं है. Just mention the modulus and argument. So your answer should be like this. Modulus of W is under root 2 and argument of W is 3 pi by 4. However, the question says find the modulus and argument of W square and W cube. Okay. Now we're going to use De Morgan's theorem, which is if you have a complex number in polar form, then if you have to find a certain power of W, let's say Wn, it's going to be r power n and cos n times theta plus iota sine n times theta. So that means modulus of W square is just r square, so under root 2 square, which is 2. And then argument of W square would be 2 times the existing argument, which is 3 by 2 pi. Six by 3 by 4 pi, yes, or 3 by 6 by 4 pi or 3 by 2. All right. And then we need the modulus and argument of W cube. That's going to be cube of under root 2. What is that? That's going to be square root of 2 times square root of 2 times square root of 2. That is 2 square root of 2. Okay, or you may directly use the calculator. And then we have argument of W cube. Argument of W cube would be argument of W times 3. So it's going to be 3 times 3 pi by 4, which is 9 pi by 4. So we have the argument and the modulus of W square and W by changing W into polar form. Okay. Next is the points in an Argand diagram representing W and W square are the ends of the diameter of the circle. Find the equation of circle giving the answer in this form. All right, so they're saying that there's a circle whose ends of the diameter are the points W. What's W? This. And the other one is W square. And where's our W square? This is the modulus of W square, and that's the argument of W square. Okay, what do I do with this? I know what is W square. W square is 2 cos 3 pi by 2 plus iota sine 3 pi by 2. Can you give me this in rectangular form, in the regular format? Give me 2 times cos 3 pi by 2. क्या आता है? टू टाइम्स मुझे ही करना पड़ेगा 2 times cos 3 pi by 2. मैंने एक चीज नोट किया है कि मैंने आर्ग्यूमेंट्स गलत निकाले. आर्ग्यूमेंट पाई से बड़ा नहीं हो सकता. I'll have to fix that. Both the arguments need to be fixed. Remember, an argument cannot be bigger than pi or less than minus pi. So how do we fix that? Let's see where's 3 pi by 2 on a complex axis. 3 pi by 2 is how many degrees, by the way? 3 times 180 divided by 2. Okay, so it's 270 degrees. So this is from here to here, it's 3 pi by 2. But the argument must be between pi and minus pi. So we must just consider this angle, which is 2 pi minus 3 pi by 2, which is just 90, which is pi by 2. So the argument is negative pi by 2. Instead of this, you write 90 degrees, or in fact, negative 90 degrees. So minus pi by 2 is the first out. Secondly, 9 pi by 2 is what? 9 into 180 divided by 4 is 405. Where do I plot 405? My 405 minus 360 is 45 degrees. It's exactly here. This would be 405. You give it a one complete round trip and then you add another 45 to it, and that's how you get 9 pi by 4. Okay, 9 pi by 4 is 405. 9 into 180 divided by 4. So अब 104 डिग्री एंगल कैसे प्लॉट करते हैं? एक कंप्लीट राउंड ट्रिप इज 360 और 360 से आगे फिर 45 डिग्रीज जाना है. So we will instead just write 45 degrees instead of that, and 45 degrees. All right. So let me just turn off the camera again. All right. So then 405 minus 360 is 45. So this is 45 degrees. However, we're in radians, remember, so radian equivalent of 45 is pi by 4. So you get pi by 4 here. So this is not 9 pi by 4. It should be pi by 4. All right. So let me just change that to minus pi by 2, although it won't make any difference here. But modulus on argument में marks काफी कट जाते हैं अगर मैंने उसको convert ना किया होता उस angle को between pi and minus pi. So for w square, the modulus, the argument is minus pi by 2. Okay, that's 2, and then cos minus pi by 2, which is 0. So we get a 0 here. And then what is sine minus pi by 2? That is minus 1. So minus iota. So w square is just 0 minus 2 iota. The points on an eigen diagram representing w and w square are the ends of the diameter of the circle. All right. So what is w and what is w square? W tha hamara -1 minus iota. Let me just write that down. -1 plus iota, sorry. And w square is 0 minus 2 iota. So as a coordinate, this is -1 comma 1, and as a coordinate, this is 0 comma minus 2. So where would these be in the around the circle? I think SC figure then. Something like this. This would be 0 comma minus 2, and that would be -1 comma 1. All right. Now we need to write it in this form. I'm sorry, the class has gotten a bit longer. Lekin I know कि अगर मैंने ये बीच में छोड़ा तो you won't be able to do it as homework. All right, now we need to represent this in this format. So we need a center and we need a radius. So how do we find the center of 1 comma 1, -1 comma 1 and 0 comma minus 2? Let's find their midpoint, which is going to be -1/2 comma 1 minus 2 is -1, and then half again. minus half comma minus. That is the center of the circle. That's minus half and minus half. And then now find the radius. This distance or the other distance. Apply distance formula here. That would be radius equals square root minus 2 plus half whole square plus 0 plus half whole square. When you simplify this in the calculator, you'll get square root of 10 divided by 2. That's the radius. So now you have the center and the radius. Center is minus half, comma minus half, and the radius is under root 10 upon 2. Now, how do we write this in the form of z? Remember, z equals minus half iota. Bring it to the other side, so you get z plus half iota. Modulus around that is equals to radius, which is under root 2 upon 2. However, in the question, they've taken negative outside of the brackets. Look, there's negative outside. So what I'll do, I'll take minus common and then change the signs inside the bracket. So it's going to be z minus half, minus half iota. Signs have to be flipped, is equals to under root 10 upon 2, which is the correct answer. Please redo the questions we did today as homework, plus one more question after this. Okay, my homework काम इसलिए दे रही हूँ क्योंकि I am asking you to redo what we did today. Alright, I'll see you guys tomorrow. Take care. Allah Hafiz.